So today you're going to be looking at significant figures and learning what they are and how to use them. This topic has its own video because it takes a little bit more explanation, and I like to keep these videos short. So the first thing that we need to know about significant figures is they help scientists or you guys to know when to round. So a lot of times in class, if we're doing something and we see numbers, people will say, Miss Little, what do I round to? Significant figures are the rule for scientists to know when to round and what to round to every time they take a measurement. So scientists use significant figures to show the precision of a measured quantity. Precision is how exact the measurement is. So you want to be precise with your measurements. You don't want to be vague and just say, oh, it's 10 if it was 10.59. And a significant figure is a prescribed decimal place or just a determined decimal place that tells the amount of rounding to be done based on how precise the measurement is. So it's what is determined by the rules. So an example of when you might use this, suppose you estimate a weight of something that is between 2.4 pounds and 2.5 pounds, and you estimate that to be 2.46 pounds. The first two digits, 2 and 4, are known. It's what you know about the weight. The last digit, the 6, is an estimate, and it involves some uncertainty. So you had to kind of guess or estimate that. You weren't entirely for sure. All three digits convey useful information. They're important for us to know. However, and so they are called significant figures. The significant figures in a measurement include all of the digits that are known plus the last digit that is estimated. So how do we know how many significant figures are in a number? And so that's what your assignment is going to be about today. So let's look at it. Now, there are a set of rules that you can go by, and you can memorize them and check off through each of those rules. There are 5 different rules that you can use, or this rule that I'm getting ready to tell you kind of puts them all together into one thing. So this is called the Atlantic Pacific Rule. Atlantic Pacific Rule. And you can see that we're looking at a map of the United States. Who thought that this was going to be geography class? So the Atlantic Ocean is on the right side of the U.S. or the east side, but the right side of the U.S. Pacific Ocean is on the left. So the Atlantic Pacific Rule says if a decimal is absent, you start on the right side of the number and you look at that number from right to left. So you follow the arrow. If a decimal is present, meaning that it's there, then you start on the left side of the number and you read that number from left to right. So it says you start on the correct side if the decimal is present or absent and move toward the U.S., the picture. And we start counting significant figures at the first number that is not a 0 as we're reading our numbers. Let me explain. So this first number, number 1, the decimal is absent or present. Well, there's a decimal, so the decimal is present. We're going to start on the left side of the number, and we're going to start counting at the first number that's not a 0. Well, our number is 3.0800. If I start on the left side of this number and start counting at the first number that's not a 0, well, that will be this first number. And so the first number that's not a 0 and everything after it following our correct direction is significant. So this number, decimal is present, so I'm going to read it from left to right. And the first number is not a 0, so I've got 1, 2, 3, 4, 5 significant figures. On number 2, decimal is present again. So I'm going to start on the left and read it from left to right. Well, these first few digits are 0, so I'm not going to count those this time. I'm going to start at the first number that's not a 0, which is this 4. So I've got 1, 2, where'd my pen go? 3 significant figures on that one. Okay, here, decimal is present. I'm going to start at the first number that's not a 0 and count everything after it. 1, 2, 3. Now, this is scientific notation. When we use scientific notation, we're going to only leave the significant figures. So I don't worry about this part, but I am going to count all these digits. So 1, 2, 3. Okay, down here, number 4, the decimal is absent. So this is where it kind of gets tricky because you kind of have to look at the number backwards. So I'm going to start on the right side and go over. And so I'm going to start, I've got 0, don't count that, 0, don't count that. I'm going to count here, 1, 2, 3 significant figures. Okay. Number 5 is covered up by my toolbar. Let's look at number 6. Decimal is present. So I start on the left side of the number. We've got a non-zero, so we start counting here. 1, 2, 3, 4. Number 7, decimal is absent, so that's a 0. I don't count that. I've got 1, 2 significant figures. Number 8, my decimal is absent, so I'm going to start on the right side and go left. 0, don't count that, don't count that. 0, 0, 0, don't count those, don't count that. I've got 1, 2 significant figures. Decimal is present here, so I'm going to start on the left side of the number. Start on the left side and count everything over. We got a 0, we don't count that. Erase. So I don't count that, and I start here. So I count 1, 2, 3 significant figures. Number 10, again, the decimal is present, so I'll start on this left side of the number. Got a 0, 0, 0, don't worry about those. And here is my first non-zero, so I'll count this. 1, 2, 3 significant figures.